I'm not going to pass them out until tomorrow. That will give you time to look over it. They were kind of all over the place. Like I had everything from a 100 to not a 100. But do just remember, like, if your grade is below an 89 on the test, you will have the opportunity to do test corrections in the same format as the quiz corrections to earn 5 points. If that is still not up to the 89, then we can worry about scheduling a recovery test, and you can still earn up to that 89. But we definitely are, like, getting, I don't know how to say it, like, into calculus, like, really, really into it. One thing about this class is, like, anything we learn, especially with these derivative units, it never leaves us. So ultimately, it's like either you learn it now or you learn it later, but you're going to have to learn it at some point or you're just not going to make it out of first semester. Looking at this unit is called Applications of Derivatives. Where we're going to be looking at mainly how can we use the derivative to analyze the functions in lots of different ways. This unit is very, very algebra heavy. Like after you do the derivative, there is a lot of algebra, there is a lot of solving and things like that. There's also a lot of weird days, and this is shared with you on that notes page in OneNote, and I just want to kind of make sure you're aware of it. This unit is basically going to take us almost all the way to Thanksgiving break. So this week is a normal week. Next week is a weird week. So Tuesday and Thursday are weird days. Tuesday, the only people in the building are going to be 9th graders and then 12th graders who have already signed up to take the SAT with their counselor. And then Thursday is another weird day, and it's just for 10th and 11th graders to do the PSAT. They're technically asynchronous days, but since my class, like this class mixes 11th and 12th grades, and those don't have the same asynchronous days, I'm just pretending for the sake of planning that next week is just a 3-day week for calculus. Looking at this unit, there are going to be 2 quizzes in it. The first quiz is actually next week on Wednesday. The second quiz is a little bit later. And then your test is going to be that Wednesday before Thanksgiving break. So that's kind of the calendar. And then last thing I wanted to show you, also in OneNote, I shared some stuff that I'm not actually going to cover, but I thought some of you may need it / want it. So I reshared the derivative rules just to make sure you can fill those in and still know your derivative rules. I also shared with you, it says like 00 Unit 3 prereqs. So you have to be good at this unit with like being able to solve all types of equations, solving exponential equations, solving polynomials, quadratics, trig, any equation you need to be able to solve it. So if you are bad at factoring or solving, I have already filled in the notes for you, but they're just some like examples that you might just want to like look at at your own leisure if you know you're a little bit weaker with solving equations, because you have to be able to do that for this topic. And I even have a practice homework. It's an optional homework 0. Again, I'm not collecting it, but if you just know you're bad at some algebra skills, need to work on them, then I'm going to kind of put that on you to practice those skills. But we're going to start off today with learning another set of derivative rules. We're going to be looking at the derivatives of exponential and log functions. So we've looked at the main rules already in Unit 2, like we have the power rule, we have the product and the quotient and the chain, and then we have the 6 derivative rules. And so we're just going to keep adding to our list of rules. All the rules that we have learned can still apply, especially like the chain rule, the product rule, and the quotient rule. So let's review logarithms, because I know, unfortunately, that some people have not remembered kind of what a log is and how we deal with it. But if I say log base b of a is equal to c, we know that b is the base of that logarithm, and we can rewrite that as an exponential. If I rewrite this as an exponential, the base is still b, but it's like c is equal to a. So it's kind of like if I put numbers to this, if I say something like 2 to the 3rd power is equal to 8, in logarithm form, that's the same thing as saying log base 2 of 8 is equal to 3. So that's the definition of a logarithm. We will be doing lots of stuff with these logarithms, like in some of these examples we'll be reviewing like our log properties, and how we can simplify logarithms, but we're going to focus mainly today of just like how do we take the derivative of logarithms and how do we take the derivative of exponents. So the first rule that we're going to look at is probably the easiest rule that we have, and it's going to be the derivative of e to the x. E to the x is kind of like our basic parent exponential function. E is a constant like pi. It's like 2.178 da 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 da. It's a never-ending decimal like pi. The derivative of e to the x will be your easiest derivative you have to memorize because the derivative of e to the x is e to the x. So it is the only function we have in math where its derivative, the function is a derivative of itself, which is kind of unique. And there's reasons why, but right now I just need to know that, hey, the derivative of e to the x is e to the x. So as an example with that, we know that the chain rule always has to apply. Like, rarely now will we have functions where we don't have the chain rule. When we're doing the chain rule with exponents, the inside is going to be what you see in the exponent. So looking at this one, this is e to the x squared plus 4x. So that x squared plus 4x is what's inside that function. So if I want to take the derivative of it, the derivative of e to anything is just that same function. So I'm going to have e to the x squared plus 4x. And then we have the chain rule times the derivative of the inside. Well, what's the derivative of the inside? The derivative of x squared is 2x, and the derivative of 4x is 4. So yes, the derivative of e to the x is e to the x, but often we are not going to have just x in the exponent, so we will have to think about the chain rule, which is going to allow me to kind of introduce a new way of writing derivative rules, since most functions are not like the sine of x, e to the x, tangent of x, but there's something on the inside. The more common way that we're going to start writing these formulas is with a u there. Just to remind you that that u represents the inside, and that is the reminder for you to always do the chain rule. So when I say let's find the derivative of e to the u, like it is still e to the u, but we just want to remember that u prime, which is going to be our chain rule. So that's just another way of writing the rule. I like it this way because it does remind you that you have to do the chain. Go ahead and try those two examples on your own. You should be able to do this fairly quickly because there's usually not a lot of simplifying you can do with our exponential derivatives. And so whenever you see a function that is e raised to anything, its derivative, automatically go ahead and write down exactly what you see. And then don't forget about the chain rule, multiply it by the derivative of the exponent. The derivative of sine of x is going to give us cosine of x. Same thing for this second one. The derivative of e raised to anything is exactly what you see. So that's going to be e to the x plus the square root of x, but then multiply it by the derivative of the exponent. The derivative of x is 1. Remember, the square root of x is just x to the 1/2. So you can put that 1/2 in front, and the new exponent would be negative 1/2. Again, not really a lot of simplifying that you can do with the derivative of e to the u. Questions so far on that derivative? Yes, Mitchell?
So if there's a square root and there's a fraction exponent,
Mm-hmm.
you have that in the same equation.
Say it one more time.
So if you have the square root of x, and you have the negative 1/2 as an exponent, can you keep it like that?
Yeah, you can leave it like that. All right, so that was the e to the u rule. We also have a rule when we have a base that's not e. So this is going to be the derivative of a to the u, where a is going to be a number, not like a variable. So this is not the same thing as saying like what's the derivative of x squared. It's more like saying what's the derivative of 2 raised to the x. And specifically, this is going to be the case where the base is not that natural growth one, not e. So it's going to be any other number but e. The formula looks very similar. So if you're taking the derivative of something of an exponential, it's still going to be that same exponential. We still have to remember. The only difference is, since that's not an e, we're going to multiply it by the natural log of the base. So remember, the natural log is just a regular log base e, but really right now we just need to make sure that we can just take that derivative correctly. Again, the chain rule is typically going to apply for these problems, and we just want to make sure that we create the derivative correctly when we find it. So as an example, I have y is equal to x squared times 2 to the x. So if I want to find that derivative, we have to make sure we use the correct derivative rules. Again, any derivative rule that we have learned can show up. So in addition to that new rule we just learned, what other rules do I need to learn? Well, what other rules will I need to do for this problem? The product rule. So we have two things being multiplied with x in them, so we have to use the product rule. So finding the derivative of it, I have y prime. So I have the first times the derivative of the second. The derivative of the second is where this new rule is going to come into play. This is not a base e, so we have the natural log of the base times exactly what it was. Do I need to worry about the chain rule for 2 to the x? Not really. What's the derivative of x? 1. So we don't really need to worry about the chain rule. So then plus the derivative of the second times, or excuse me, the derivative of the first times the second. That's the derivative. Often I don't make you simplify things. If I were simplifying this one, I'd probably just like factor out the GCF. If I were factoring out the GCF, I see that they both have an x in common. They both have a 2 to the x in common. And then left over, we have an x times the natural log of 2 plus 2. But again, it doesn't really clean up that nicely. At least that one doesn't. Any questions on that derivative rule? Yes, Bud?
So you don't have to take it like x squared to like 2x?
Where am I looking at?
Like the first.
You can leave it like this. Is that what you're asking? No, it's not.
Yeah, it's just like x squared like times 2x and get all that for the 2x, but.
Yeah, so I just factored out the x from there and then the 2 to the x. But there's no like other evaluating you have to do for that.
Okay.
So those were the first 2 rules that we have to learn. Those are the only exponential rules that you have to learn. We also have 2 other rules I want to cover today dealing with logarithms. The first one's going to be the derivative of the natural log of x. So remember a log, when you see the natural log, that's a log base e. This is probably one of the more important derivative rules that we learn because we will see it a lot, especially second semester. The derivative of the natural log of x is going to be 1 over x. And that's if you don't have to worry about the chain rule. So the derivative of the natural log of x is going to be 1 over x. We do know, however, that most of the time we have a chain rule, so we will need to worry about actually finding the derivative using the chain rule. So an example of what it will look like with the chain rule would be if you saw the natural log of something other than x, but we can still kind of follow the general idea when we're taking that derivative. So whenever you're taking the derivative of a natural log, y prime, it's 1 over exactly what you see on the inside. And then here's the chain rule times the derivative of what you see on the inside. The derivative of the inside would be 5x to the 4th. The derivative of tangent is secant squared. Typically, when you do the derivative of a natural log, most people will just simplify that and just write it as like a single fraction. So that you would write it as y prime is equal to, there's the denominator, and here is the numerator. Please, 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 please don't cancel across plus or minus signs. A few of you tried to do this on your test, not tried to, you did, and were wrong. So you can't cancel out like that x to the fourth with some of those x to the fifths because that plus sign is keeping you from doing that. So that would be the derivative of that original y. So again, when I do the derivative rule, so yes, the derivative of the natural log of x is 1 over x, but most of the time we have something that besides just x on the inside. So I think it's easier to think about the rule as the derivative of the natural log of u is just 1 over what you see on the inside times the derivative of the inside. But that u prime is just your reminder that you always, always need to consider the chain rule as a possibility. So go ahead and try these two examples for me. Again, these are two that you should be able to do fairly quickly. And just for practice, I do want you to simplify that first one completely. So I have y is equal to the natural log of sine of x, and then I want you to also find the derivative of the natural log of 2. And then we just have one more rule to learn after this one. So if I have y is equal to the natural log of the sine of x, finding its derivative, y prime, so we have 1 over the inside times the derivative of the inside. The derivative of sine of x is cosine of x. So this is really just saying cosine of x over the sine of x. Can simplify this one. What do we want to say the derivative of the natural log of sine of x is simplified? Cotangent. And then the second one might be a tricky question. What's going to be the derivative of the natural log of 2? 0. So don't overthink this one. The natural log of 2 is just a number. So it's technically just a constant. So what's the derivative of all constants? The derivative of a constant is 0. I guess you could have done it the long way. If you did it the long way, it would be 1 over the inside times the derivative of the inside, but you're still getting 0. Yeah, go.
What if you have something in front of log?
Would it be a variable or a number?
Either one.
So the question was, was at home if you had something in front of the log. So if it was written that way, that's still just a constant. So it's 3 times a constant. So its derivative would be 0. But if you had, say, like an x in front of it, then that natural log of 2 is actually acting like a coefficient. So it's like same thing as saying like take the derivative of 3x, which is just 3. So the derivative of this would just be the natural log of 2.
All right.
Because you just want to think of that as a number, like it's serving as like a coefficient or a constant.
Okay.
Good question though. All right, and then I know we're going through this real quickly. Other problem in chemistry fun. So if I'm doing the natural log of u, like its derivative is 1 over u times the chain rule. Sometimes we don't have natural logs, like if I have log base 10, log base 7, log base 2, basically anything that's not a natural log. The formula is a little bit different. It still has 1 over the inside in it, like that's not changing. You still have to multiply by the chain rule. But similar to the a to the u formula, where you have to multiply by the natural log of the base, for the log one, you have 1 over the natural log of the base in the denominator. So that is going to be the derivative when you have a log of a base that's not e, so a non-natural log problem. So for the example I want you to try for that one, Cool, looks like I didn't add one. I'm gonna make one up real fast then. So the example I want you to try, take the derivative of the natural log, excuse me, not natural log, log base 7 of, we'll say x squared. Do that derivative. Take the derivative of log base 7 of x squared. So if I'm taking the derivative of log base 7 of x squared, so its derivative, we have 1 over the inside times the derivative of the inside, which is 2x. But this was not a natural log, so I have 1 over the natural log of the base in the denominator. Could leave your answer like this, like that's perfectly fine, 2x over the natural log of 7 times x squared. But one of those x's does cancel, and you can write it as 2 over x times the natural log of 7. So just to review, because I feel like I'm talking fast, but I think these rules are pretty straightforward once you get them memorized and able to use them. So these are the 4 rules that you have to know added to the ones that we've already learned. So you have the natural log and the base log. The derivative of the natural log is 1 over the inside times the derivative of what you see on the inside with the chain rule. When it's a log that's not a natural log, very similar formula, but we're kind of also dividing by 1 over the natural log of the base. That kind of lets you compare and contrast those 2 formulas. And then we also have 2 exponential formulas you have to know. The 2 exponential formulas you have to know is e to the u. The derivative of e to the u is just e to the u, but don't forget about the chain rule. Whereas if that base is not an e, any other besides e, it's still the same thing, but you have to multiply by the natural log of the base. I think by seeing all 4 of them at the same time, it does allow you to compare and kind of contrast them. Again, there is no formula sheet on the AP exam, so those formulas definitely do need to be memorized. Questions on those formulas? All right. So for homework, it's in your textbook, but I sent it out to you via OneNote. It's just a bunch of finding derivatives, because you do want to make sure you're good with finding these derivatives so that you can do stuff with them. So far, we have really only looked at finding like horizontal tangents and the equation of tangent lines, which I can definitely do with these problems. But this whole unit, the rest of it is all about like how can we do other things with derivatives. So your homework, if you're looking for it, it is in OneNote. But I'm having you do, well, you can read. I'll let you do those problems. Other things that you can also look at, like if you know you're bad at algebra, you might just want to sometime peruse like those intro notes you see in OneNote of like the prereq stuff, and maybe just like glance at the optional homework 0, which is underneath the notes in OneNote. But really what we want to look at moving forward is like making sure we're staying caught up, memorizing these rules, and knowing how to use these rules correctly. So you can use the rest of your class period to go ahead and get started on that homework. And we'll start the next topic tomorrow. That will give you about 30 minutes to get a lot of that homework done. The answer key is posted online. Don't have to simplify any of your problems unless it asks you to. So you're more than welcome to leave them unsimplified. Whether you're at home or at school, definitely let me know if you have any questions.